Verification of Newton's second law. Epoch of S of mass, we have the mass is equal to 100 grams, so it's equal to 0.1 kilogram, may slide along an inclined track that makes an angle with the horizontal such that sine alpha is equal to 0.4. So G moves on this inclined plane, and we have the angle here. So we release that without initial velocity. This means here we have the speed is equal to 0. And at the end of each interval of time, you have tau is equal to 50 milliseconds. So between each 2 points, we have this tau. We record the position, which are given by the abscissa x. So this is the origin of the abscissa, and you must notice here that PEG is equal to 0 at this position here. So now, verify that the speed of the puck at the instant t2 is equals to at the instant t2 equal to 2t and t4 equal to 4t tau are v2, so you have to verify this speed. In order to verify the speed, so we must find it. So we'll say here in the first part that v2 is equals to, so we'll take the 2 points which are before and after the point 2, so which means we will take is g1, g3, which is over 2 tau. So when I say g1, g3, this means it's equals to x3 minus x1 and over 2 tau. Now when I talk about x3 minus x1, this is what we call x3. And this is what we call here x1. So it's equals to 4.5 minus 0.5, but must pay attention, this is in centimeter, so times 10 to the power minus 2, and over, here we'll have it's over 2 tau, such that tau is equals to 50 milliseconds, so times 10 to the power minus 3, and here the answer then will become is equal to 0.4 meter per second. Now the same thing is in order to find v4. v4 is equals to g3 g5, so it's over also 2 tau, which means equal to x5 minus x3 over 2 tau. When I say x5, then here is it, so it's equals to 12.5 minus x3, this means 4.5, all times 10 to the power minus 2 and over 2 tau, so 2 times 50 times 10 to the power minus 3, and the answer then will become equal to 0.8 meter per second. So this is verified. Now part 2a, calculate the mechanical energy at the instant t0, t2 and t4, knowing that you have this is the gravitational potential energy, the reference. So ME at t equals to 0, it's for this system, back Earth, is equals to KE at 0 plus PEG at 0. But in the given, you don't have speed, it was released without initial speed, so this is equal to 0. And also it's on the reference, so if we look here, it's on the reference, so there is no height, then this is also equal to 0, so the answer will be 0 joules. Now we continue. ME2 is equals to KE2 plus PEG2. In order to find KE2, so it's equals to half mv2 square, mv2 square, we already find v2, which is equal to 0.4, and plus PEG2, which is equal to mg times z2. Now here we must find z2. In order to find z2, I must look at the figure and find the height, or trace the height. This means I must trace the height. So let's suppose this is here g2, then this will be the height here. Must pay attention, it's below the reference. So here I will say that z2 is equal to minus height 2. So it's equals to, if we look at the angle, if this is alpha, then this is also alpha. So the height is opposite, so we'll use sine alpha. So it's sine alpha and times this hypotenuse, and this is what we call G0, G2, which is who? Which is x2. So this is x2. So I'll write it here. So it will become minus x2 sine alpha. And then here I can find the mechanical energy. So here we'll get as answer is equal to minus 0.008 meter. Since we have here it's 2 times and you have 0.4 as alpha, and then we'll get as mechanical energy. So if we continue, we'll here me2 equal, this means half times the mass, which is equals to the mass 0.1 times v2 square, which is equal to 0.4 all square, and minus 0.008, this is z, times m 0.1 times g times 10. So here we'll get as answer is equal to 0 joules. We continue and we'll find now me4, me at the point 4 is equal also half mv4 square plus mgz4. So equal half the mass is 0.1, we have v4, here is it, it's 0.8 square plus also the mass 0.1 times 10. Now in order to find z4 is the same way, but the difference is now that the hypotenuse here it's x4, which is equal to 8 centimeter. So here it will become z4 will become equal minus x4 and times sine alpha. And so here we'll get as answer it's equal to 3.2 centimeter, which is equal minus 0.032 meter. And we substitute minus 0.032, and at the end the answer will come equal to 0 joules. So we notice here we have 0 joules, here we also have 0 joules, and here also we have 0 joules. So why can we suppose that the puck moves without friction? Part B. So since me at 0 is equal to me2 is equals also to me4 equals 0 joules, we have the same value, then this means it's equals to constant. So we can say implies the mechanical energy is conserved. If the mechanical energy is conserved, this means no friction on the track. Now, part 3, determine the variation of the linear momentum P4 minus P2. So delta P is equals to P4 minus P2 vector. So it will be equal m v4 vector minus m v2 vector. And you already have v2 is equal to 0.4 meter per second and v4 equals 0.8 meter per second. So here the answer will become equal to, I can take m as common factor, v4 minus v2, so we'll have as answer 0.04 I. Why? Since here if I want to substitute, I will put 0.1 times 0.8 I minus 0.4 I. Then we'll get this answer. Now we continue. Name the forces acting on S during its motion. So what are the forces acting? We have the weight and we have the normal. These are the forces. Since there is no friction, we continue part B. Show that the resultant force is given by this equation. So summation of F external is equals to, let us trace the forces. So we have here the weight, we have here the normal reaction, and the x-axis is downward. So we have the weight plus the normal, but the motion is along x, along I vector. This means, and I can remove it, so we'll have summation of F external is equals to W. Now W along x, if we notice, this is Wx here, so it's opposite to alpha, so we'll use sine. So it's equal mg sine alpha, and it's along I, so it's I vector. So this is verified. Now part 5, assuming that delta t is very small, that we can say delta p over delta t is equal to dp over dt. Show that Newton's second law is verified between T2 and T4. In order to show this, then we will apply it. So I will say here, summation of F external is equal, I will do the substitution, so we'll have summation of F external is equals to mg sine alpha, and I have the value, so it's mg sine alpha I, which is equal to 0.1 times 10 times sine alpha 0.4 I. So we'll obtain 0.4 I. But we know that, so the question is very far, but we know that we can find also delta p over delta t, which is equal, so we got delta p, we have it is equal to 0.04 I, and delta t, which is between T4 and T2. So between T4 and T2 we have it's T4, this means it's 4 tau minus 2 tau, which will give us 0.04 I over 2 tau. This means 0.04 I over 2 times 50 times 10 to the power minus 3, and then the answer will become equal to 0.4 I. So here we get the same answer, and the question is to verify this law. So I will tell him now summation of F external is equals to delta p over delta t, then the law is verified.